Okay, so what you would do, you move your NN, like on the top one, you move your NN over, and so you have N0 equals 60 minus N.
You could solve it by substitution. By substitution, Eric says N sub 0 is equal to 60 minus N sub N.
Oh, God.
You okay? So from this, just one way you could do it. From there, then you substitute, and then then you're going to take your second equation, and then I'll get to what Aaliyah said. Plus 10, but N sub O is 60 minus N sub N equals 310. So you would go ahead and solve that. So you would use the distributive property. You would group like terms together. You would subtract 600. Subtract 600. I think that's going to leave you with negative 290. And then you would divide by negative 5. So N sub N would be equal to, I think, 58, if my calculations serve me correctly. Then what would you do? Because is that all we want to find?
Yeah.
Yep. Then you need to substitute that back in. So I would, if it were me, I would take that and I would substitute it in right there. So you get 60 minus 58, which is what? 2. So then you get that. What else could you do? You could eliminate them. To eliminate them, what are you going to do? You could divide the bottom one by 5. You could multiply the top one by negative 5. What's an easy number to always multiply by? 10. So I could multiply by negative 10, which gives you negative 10 N sub N minus 10 N sub O equals negative 600. And then you have 5 N sub N plus 10 N sub O is equal to 310. So you get negative 5 N sub N is equal to negative 290. And you divide by negative 5 and you get your 58 again, and then you could substitute it back in. If N sub N is 58, 58 plus 1 is 60. You find out that N sub O is equal to 2. You could do that. Now, Aaliyah said something about, can't you get rid of something? Didn't you say the other day about getting rid of something? Yeah, you could rewrite the equation. When you rewrite the equation, do I want to get rid of the subscripts? No. You want to get rid of the big. So this would be N plus, here's the problem, and that's why I put it as a 0. It's actually an O. But when you write it, what does it look like? A 0, and you would just say N is equal to 60. So if you're choosing to eliminate the capital N, how do you write a cursive O? With a little swirl on it? Change it to something else, and then just keep in mind what it was, and then in your answer you can change it back. Maybe put it as a Z. Or if you were to look in the book on page 80, because it says a subscript right here, that's how you know. So when you write it up here, you got to be careful. You know that that's a 0, not, or that's an O, not a 0. Well, when you go to solve the problem, if I just give you that right there, n plus 0 equals 60, you subtract 0 from both sides and you get n is equal to 60. But that's not your answer. So it's when you look at this as a subscript, put it in and you misinterpret it as the number 0 instead of a variable. Variables are letters, right? The letter O looks like what number? 0. So you're going to get in trouble if you do that. Unless you do Jackson's cursive or something. You could write it as this. Or something. So yes, Aaliyah, you can do that. Be careful. An example of this, you would probably see a D there, and you would say the numbers of nickels and dimes that you have in your pocket. You have a total of 60 coins, and then nickels are worth 5 cents, dimes are worth 10 cents, and you have a total of $3.10. How many nickels, how many dimes do you have? I put a 0 there, just one, to make you realize that subscripts aren't always referring to money. 2, because the example that I pulled this from is actually a subscript of 0. And 3, because when you get rid of that, the capital N, when you get rid of that, then it changes and it looks like the number 0 instead of a variable O. Okay, another example. Others that we worked through the other day look something like this. These are also subscripted variables, and Landon was really, well, Landon was the one that told us what these mean. Subscripted variables just give you more descriptive variables. More descriptive variables. And we talked about this one. Do you remember an example that I said this one might relate to? Nothing. You won't have a 2 with a subscriptive 3. You won't have numbers that way. Subscripts, okay, so like if I talked about the class right now, and I wanted to write an equation that dealt with the class, if I wanted to deal with an equation that dealt with the class, I might have something like it looks like that. What do you think that's referring to? The boys to girls. Does that make more sense than if I just say this? Yeah, it means more sense. But here's the problem. So variables are representing something. Who drove to school today? Lots of you, right? How fast did you drive? 65. On the gravel? No. How fast did Macy drive? She better not have drove 65. 20. So here's the problem. We have the rate you drove to school at. What rate did you drive to school at? 65. We have the rate that Macy drove to school at, which was 20. R can't be both of those. So this is the rate that Eric drove to school at, and this is the rate that Macy drove to school at. They're both referring to your speed. It's just that it's different people. Does that make sense of what your subscripts are? So that's what this example leads you to, is distance is equal to rate times time. So if we look at it, this is the distance that Wilson drove to school at. He drove so fast for so long, and that's how far he went. So if you go 60 miles per hour and you travel for 3 hours, how far did you go? 180 miles. So that's what Wilson went. Oh, maybe I better change my problem here. That's not going to make any sense, is it? And then we have Mark. because I don't know anybody in here. Oh, Macy. Here's Macy. Okay, so we have Macy, and this is how far Macy goes, because we're going to take her speed of 20, and she drives, sorry, unrealistic through town, for an hour. How far did she go? 20 miles. What we're doing is we're adding their two distances together and saying that they went 380 miles combined. They went a total of 380 miles. So if Wilson drives at 70 miles per hour, and Macy drives at 50 miles per hour, and the combined time that the two of them drive is 5 hours. I want to know how long did each one of them drive for. We can solve this by substitution, then do substitution elimination or something. We solve. What can I do? I know what this single variable is, right? R sub W has a value of 70. So I'm going to put 70 in for that value. That's the rate Wilson drives at. Then we also know that Macy drives at a rate of 50 miles per hour. So I can put that in right here. Macy drives at 50 miles per hour. So that's going to make that equation look like this. 70 times the time that Wilson drives plus 50 times the time that Macy drives for, each one of those finds the distance, is equal to 380 miles. And we know that if I take the time of Wilson plus the time of Macy, keep in mind I switched those two variables around. They drive for a total of 5 hours. Why? Excuse me, I got the hiccups. Why did I switch those two around? Because they were underneath the wrong variable. I want Wilson's time underneath Wilson and Macy's time underneath Macy. So now, how can I solve that? Elimination or substitution. Yes, you could make that easier, which someone said for the last example that I gave you. Somebody said divide everything by 5. Who said that? Colby did. Colby told me on this equation we could take the bottom one and divide everything by 5. I think it's easier to multiply by 10 because 10's easy to multiply by. But you could divide everything by 5. Do you notice anything about that top equation? What about 70, 50, and 380? Divide by 10. You could, if you wanted to, change that problem to 7W or T sub W. I've got to keep that down there so I know it's Wilson's time and not his rate. And I'm dividing it. Let's try this all again. So if I divide by 10, you get 7 T sub W plus 5 T sub M is equal to 38. These two equations right here are equivalent equations. You could use either one. Most people don't see to simplify the number. If you want to, you can. But if I just do elimination substitution on these two equations, what would you multiply by? That's not going to eliminate. Negative 70, that would work. If I multiply by negative 70, the top equation is still 70 T sub W, which means the time of Wilson, plus 50 T sub M, the time of Macy, equals 380. What does this bottom or second equation become? Minus negative 350. So Wilson's time cancels out. We get negative 20 T sub M equals negative, positive 30. So we divide by and what are we ending up? T sub M is negative 3/2. Okay, now that I know that that is not making sense based off of the example that I gave you, but that is the correct value they want. The Wilson doesn't travel for -1.5 hours, okay? They're not worried about these making sense. They're just worried about you being able to get values. So now how do I find T sub W? Put it back in. I would use the equation that we had, which is this. And we're going to, sorry, Macy doesn't travel for -1.5 hours. I think I said Wilson. So we put that in here, and you get -3/2 plus T sub W is equal to 5. So you add 3/2, and when you add 3/2, you get T sub W is equal to, yes, 5 3/2, but we don't leave it as a mixed number and improper fraction. So what is that the same thing as? Did you say? Okay, 13/2. 6 1/2. I don't know what it is. These are the correct answers. I know you don't, when I start referring to rate and time, I'm jumping ahead telling you what those equations could represent. They're just wanting you to solve. Okay with that? It's still elimination substitution. You just have subscripts. That's all. All right, the next thing. Possibly. Yeah. But they may not be. Oh, you're wanting those? Had I known we would have a lot of people down today, I maybe should have. I need to get those printed off. I have generated them now 3 times, and I keep forgetting to send them to the printer.
Wait, what?
Your map testing results. I have to generate them, and then if I generate everybody's, then it takes a while for it to generate. Then after it generates, then I'm in class, and then I don't always get it sent. Okay, this right here. What if I ask you? What if I ask you to solve? What is x? What is y? Here's the thing. How many variables do you have? Variables. 2, x and y, right? If you have 2 unknown values, you have to have at least 2 equations to solve. 2 unknown values means at least 2 equations to solve. If you have 3 unknown values, x, y, and z, how many equations do you think it's going to take to solve? 3. What can you tell me is true about that statement, or that figure? Yes, we know that right here you have a straight line, right? So we know that 7x minus 2y is, plus 50 equals 180. I will agree with that. What else do you know is true? Okay, now I got lots of things going on. Now what? This angle right here is equal to that angle right there. What's that relationship called? We have parallel lines cut by a transversal. Those are corresponding angles. So now we have this equation where I know that 5x minus 10y is equal to 50. Can you solve that and find out what x and y are? Yeah. Elimination substitution, right? I would probably take this top equation and I would do something with this 50. What would I do with it? Subtract it, which makes this side over here what? 130. So I would write my equation, whoops, go back to this color. So I would write it like that. Elimination substitution, what would you do to eliminate? Do what? If you, that is correct to substitute is what Aaron was saying, but when you move the 7x over, you're going to get a fraction. You're going to get 7/2. So if I take the top equation times -5, The top equation times negative 5 is going to give you negative 35x plus 10y equals, what's 5 times 130? Negative 650. No. If you solve for y, you would get a fraction. If you solve for x, you would not. Because you would add 10y and divide by 5, which would make it 2 and 10. If you move the 5 over, you're dividing by 10, so you would have 5 divided by 10, which is 1/2, then you would. The bottom equation is just going to remain 5x minus 10y equals 50. So you get negative 30x. The 10y's cancel, and you get negative 600. So when you divide, what is x equal to? 20. Oh, come on. Move. So you divide by negative 30. Zeros drop out. Negative over a negative is a positive, and you get 20. So x is 20. What is y? You substitute it back in either equation. 5 times x minus 10y equals 50. So this gives you 100 minus 10y equals 50. You what? Okay, subtract 100 from both sides, and you get negative 10y equals negative 50. So what is y equal to? 5. So let's see if x is, let's just calculate here. So we have 5 times 20 minus 10 times 5. What's this angle measure then? 5 times 20 is 100 minus 5 times 10, which is 50. 100 minus 50 is 50. Did we say these angles are equal? Yes. If I put it into the top spot right here, you're going to have 7 times x, which is 20, minus 2 times y, which is 5. 7 times 20 is 140, minus 5 times 2 is 10, which gives you 130. If this is 130, it is. If this is 130 and this is 50, that creates 180 right there, correct? So we have our x and we have our y values. I'm going to give you one more. I'll let you try this one on your own. This is going to look even more complicated yet. That cross is right there, okay? Even though it doesn't look like it. 20x plus 5y. This is 40. This is 2x plus 5y. And this is 110. I want you to find x and y. Okay, so I said something about vertical angles. I don't know if any of you were trying to go 20x plus 5y plus 40 plus 2x plus 5y equals 180. That's true, and you could simplify it, or you could just make note what each one of those angles are. Vertical angles are equal. So this is 110. So I know that, let me get rid of some of these lines here. Shorten this up so I have some room to write. So we know that 20x plus 5y is equal to 110. And we also know that 2x plus 5y is equal to 30 degrees. Now, you are not incorrect if you say 20x plus 5y plus 40 plus 2x plus 5y equals 180. But you would need to simplify that. All right, so if these are the two equations we have, eliminate. Take the bottom one times -1. So you get 20x plus 5y equals 110. -2x minus 5y equals -30. So 18x is equal to 80. You divide by 18. So x is equal to, divide by 2, and you get 40/9. Now, it's going to be kind of yucky to put 49 in for x into either one of those two equations. What I would prefer to do, you can substitute. By all means, put 49 in and work through a fraction equation. But what I would choose to do is go ahead and take that those two equations again, 20x plus 5y equals 110, and 2x plus 5y equals 30. And I would eliminate the x's this time. So if you eliminate the x's, you would take the bottom equation times what? -10. So you get 20x plus 5y equals 110. And the bottom equation becomes -20x minus 50y equals -300. So now when you subtract, you get -45y equals -190. And if you divide by -45, y is equal to, divide by 5. 5 goes into, divide by -5. 5 goes into 190. 3 gives you 15 with 4 left over into 48 times. 5 goes into 45 9 times, and you end up with 38 minutes. But you see how elimination substitution is an important process to learn. You will be using that process multiple times from here on out in math, trying to solve. You don't have to. And when you were working on your worksheet, you actually started by doing elimination twice. Then you went to substituting it in to find the other value. On that elimination worksheet.